So question 35 in the reading, right? We're doing a coffee cup calorimetry, and we've got basically this reaction taking place where zinc is going to react with HCl to produce zinc chloride and hydrogen gas and heat. It's exothermic, it's going to release heat. So, all right, I add 12 grams of zinc to this water, and the water is 0.5 liters of 0.8 molar HCl, right? And when I do that, the temperature of this water goes from 25 to 31.9 degrees. So the water goes from 25 degrees to 31.9 degrees Celsius. Right, the density of the solution bed of water, right? What's the delta H for this reaction? So there's two separate things going on here. Number one, right, it's a calorimetry problem because I have to find Q equals MC delta T. I can find the energy that the water absorbed to go from 25 to 31 degrees Celsius. And then I'm going to say, okay, that water came from the reaction of zinc in this reaction, zinc with the HCl. So then I can find, like I did before, basically the heat per mole of this reaction. So the first thing I would do is that, you know, Q equals MC delta T, and this is for the water. Right, so Q for the water, 0.5 liters is 500 milliliters, right? 0.5 liters is 500 milliliters. The density, they tell you to use the density of water, 1 gram per milliliter. So I have 500 grams of water. 4.184 joules per gram degrees Celsius. And my water goes up 6.9 degrees. My change in temperature for the water. So 500 times 4.184 times 6.9, right? I get like 14,434 joules of energy that the water absorbs. So what does that tell us about the reaction? Yeah,
It's going to be releasing that.
Yeah, exactly, right? The reaction had to release 14,434 joules of energy. So we're not quite done yet because we're looking for the heat of the reaction, remember, in kilojoules per mole. So 2 more steps. We can do the easy step first, I guess. I have to convert joules to kilojoules. So, all right, 14,434 joules, right? I know there's 1,000 joules in 1 kilojoule. So we've got 14.434 kilojoules of energy released in this reaction. And just like we did before, I need to find the moles of zinc in this reaction. So I've got 12 grams of zinc, right? We go to the periodic table. We look up that zinc is 65.38 grams for 1 mole of zinc. So 12 divided by 65.38, get 0.1835 moles of zinc. All right, so the last step, we're looking for energy in terms of kilojoules per mole. So, okay, the reaction releases 14.434 kilojoules when 0.1835 moles of zinc react. So just divide those two numbers. And I get a heat of reaction of around like 78, 79 kilojoules per mole. The trick here is really, really, really sneaky. Because they gave us the volume of the water as 0.5 liters. So we have one significant figure in our volume that we use to find our mass, which we use to find Q, which we use to find Q of the reaction. So they are looking for the final answer as one significant figure. So we would say -8, -8 e⁻⁴ kilojoules per mole. Excuse my childlike handwriting there, and then